As we continue moving west, we have Alberta and we have iTrez Research. They do remote sensing from aircraft, but a lot of the instrumentation has applications and shares data with space-based instrumentation as well. And a lot of this kind of hyperspectral research, a lot of the instrumentation that comes from these types of cameras had its roots in development for space operations. And then it filters back into things, as I've noted here, with the European Space Agency, this company performing an environmental study using its hyperspectral imagers. What hyperspectral imagers, what's unique about them is the fact that they provide high resolution data in the spectral range. So it's like looking at a rainbow in really fine detail at the various colors that make up a rainbow. So instead of having red, you have light red, dark red, burgundy. So you're really starting to see all of these different wavelengths of light, and that's basically what hyperspectral cameras do. And this added information provides more insight into what we're doing to the environment and how the environment interacts with itself. In Saskatchewan, we have SED Systems, and contrary to what the smaller dishes are made up to do, these are massive systems. These are, you're talking about 30-meter diameter dishes that do communications and do a lot of communications like with spacecraft like RADARSAT. They also do have applications in deep space missions, and SED Systems provides these ground segments, as they're called, to not only Canadians but around the world. They deal with organizations in Asia, they deal with organizations in Europe, and they're the primary source of operations for the Canadian Space Agency in Montreal. In Manitoba, we have a company called Bristol Aerospace. They're now a division of Magellan Aerospace, and they're Canada's main source of rocket propulsion technology and rockets. And they actually go way back into the 60s and 70s, where they developed what are called sounding rockets. And these sounding rockets would be equipped with instrumentation not to go into orbit, but to simply go up into space, above 100 kilometers, and actually experience the vacuum of space to make measurements. So here you have instrumentation that would be making measurements to make measurements on the northern lights and what the near-Earth space environment and its interactions are. So things like when the sun's charged particles hit the atmosphere, what's the chemistry that goes on there? And that's the kind of research that are performed on these sounding rockets. And Bristol Aerospace is a major manufacturer of them. And until the late 80s, early 90s, they were launching these rockets from Churchill, Manitoba. And since that time, Churchill, Manitoba has basically been a dormant launch site, but there is a movement now that's growing that within the space industry that's saying that Canada should have its own launch capability, and Churchill represents an easy place to start doing that again because a lot of the infrastructure is there. And I'll get into why why having our own launch capability becomes an important factor in our involvement in space. Coming a little closer to home, we have Sova Technologies based here in Ontario. It's actually just north of Concord, Ontario. And they do development on really radical designs for propulsion systems. What we have here is a system that was designed and built here, and is actually being used down at a university in the States doing some NASA research. And it is a small aerospike engine, or following those kinds of principles. So you get it makes it a really safe style of engine, and you get lots of performance out of it. And this is the kind of design strategies that NASA is using now to sort of further its development and further its access to space, because a lot of people recognize that the shuttle is not the most ideal system to get into space, because for the solid rocket boosters, for example, once they're lit, they can't be stopped. And that's one of the things that was a critical issue in things like the Challenger accident, is the fact that if there is a system that they detect is a problem, they can't do anything about it with the shuttle. Basically, the shuttle goes up and there are very few windows of opportunity where you can bring it back. Whereas technologies like this enable the pilots of spacecraft to operate them a little bit more like jet airplanes by throttling them up, throttling them down, turning them off, starting them up again. In Quebec, besides the Canadian Space Agency, there is also NGC Aerospace. I mean, there are a number of companies in Quebec, but NGC Aerospace has been doing some simulation development for landing on Mars. Not doing it with humans, and not doing it we're doing it robotically in the sense that completely autonomous. Right now, with missions like Phoenix, there's a lot of human interaction with once the lander starts to deploy and gets close enough that it's firing its rockets and getting ready to do its landing. There's a lot of human involvement in that, but NGC is doing research into completely autonomous landing. So basically, the NASA control centers and other agencies around the world, they want to launch something goes into orbit around Mars, that's all they need to know, and then they don't hear from it again basically until it's successfully landed and deployed all of its equipment. So this becomes important in terrain like you find on Mars and in the variety of places that we want to go on Mars, because there's a lot of big rocks, and much like a turtle when you flip it on its shell, if you have a lander that lands on a rock and rolls over, there's diddly squat you can do about it. So you've just spent $3 billion to land something upside down. So that's space agencies around the world like to avoid that. That's not the kind of publicity they like to get. In New Brunswick, we have a company called Measurand Inc. that they do shape and motion capture technology. This becomes important for things like astronaut training, and what it enables an astronaut to do is enables them to perform extravehicular activities without actually going into this big pool. Everybody, I don't know if everybody's seen these pictures of the astronauts when they're all decked out in their spacesuits and they're going for a swim in this massive pool. Well, actually what this technology enables them to do is actually just step into a regular room, put on these fancy gloves and suit, and then put on virtual mask, and then actually walk a mission, and actually be able to sort of crawl across things like the space station, just all doing it through virtual reality. And right now, there's the astronauts already do that to a certain extent, but they're actually right now seated in chairs, and they have the big visor, and they do all of these things. But this adds another level of fidelity to that training. So now there's less time that they have to spend swimming in a pool. They can actually just do it this way. In Nova Scotia, there is OEA Technologies. They do a lot of work in remote sensing for marine applications, and they do search and rescue, science, coastal mapping, all of these kinds of things. So really using the data that's provided by Canadian space assets and bringing them together and making them a seamless process for use in, as I said, in search and rescue and military operations, because as it stands now, the northern border of Canada is highly disputed in the international community. And it's data that comes from space assets like RADARSAT-1 that is critical in the monitoring of things that are like the Northern Passage. One thing that global warming has contributed to is the fact that a lot of the ice sheets up in northern Canada are receding and opening up a lot of passages for shipping that didn't exist previously. So now you have foreign merchants actually going through Canadian waters, and that becomes a problem when they start doing things that are not exactly environmentally friendly, like dumping their bilge overboard and all of these things. And because the Northern Passage is so remote, there isn't any easy way